Assalamu alaikum. Today we're gonna talk about experiment 9, which is about logic circuit. So this is our outline for today's experiment. First talk about the objective, then we're gonna go talk about a little bit about the logic circuit, what we mean by them, and then we're gonna highlight some important notation that you need to know about any kind of logic circuit. So you have to know how to find the Boolean expression for the logic circuit, and we're going to have example to convert logic circuit to Boolean. And similarly, another important information that you need to know and to study the possible output for the logic circuit by using truth table. So we're going to learn what we mean by truth table, how we build it, and how to convert the given circuit or Boolean expression to truth table in order to study the output for the circuit. And lastly, we're gonna talk and show you how to connect the logic circuit in practice. So this is our objective. First of all, to learn about logic circuit in general, what we mean by them, how to connect it, how to identify the symbols on it, how to distinguish the number of input, the number of output, and then we want to learn how to convert the logic circuit to Boolean expression, so how to represent it in equation based on the basic logic gate that we have talked about it in the last time. Then we want to study what happened for the output for a logic circuit by looking for the truth table, and we want to learn how to connect a logic circuit using multiple IC in breadboard. So logic circuit, if I want to define it, it's just a combination of basic logic gate, not, and, or connected together. So if you bring any kind of combination of and, or, not, or any kind of combination, bring it together, you build the logic circuit. So this is a typical example that represents a logic circuit. You can see that has or, it has and, it has not. Not should be having all the three together. It's possible to have only two gates, and you fulfill the definition. So if you bring two gates, it's like the minimum requirement to have a logic circuit. Even the symbol itself is considered as a logic circuit. So we want to learn how to study this logic circuit and study it by looking for the symbol. So the first thing that you need to know in order to study the logic circuit is to write down the Boolean expression for it. So what I mean by Boolean expression is a way of writing the logical operation in terms of mathematical equation where it follows some Boolean rules and it's different from algebra. So it's like an equation to represent what kind of operation that you can do in the circuit in order to study what happened between the input and output. So for example, for this circuit, I want to write down the equation that represent the relation between the output to the input. So rather than of representing as a circuit, I want to represent it as equation. So if I want to simplify it, I want to study what happened between input and output, it's easier in that way. So it is another way of using the studying the logic circuit. First of all, try to identify the intermediate connection. Let's say that this is the output for this logic gate is W. I call it any name, so I call it W, and I call this output by Z. So now I want to go gate by gate. I need to know the equation for each gate and based on the relation between input and output. So this is what we learned last time. For each logic gate has some certain operation. So and if you don't recall it, it should be written as a multiplication. So if I want to write the relation between the output X and W and Z, since this is the input we're gonna enter the gate, so this is the relation. So in order to write down the equation, I prefer to start from the output and go back until to reach to the input. So it starts from the output, the last gate, and I go back and study whatever I have before. So what I have in here, I'm having OR, so this is the symbol of OR, and it has the input AB and its output W. So if I want to write the relation for OR is A or B. While for NOT, it has the relation only with one input, which is C, and this is the output, so the output is gonna be written as C dash. So this is what we learned last time for each logic gate, how to write the Boolean expression. Now I want to combine or substitute what I defined at the beginning, W and Z, in order to find out the relation between X and ABC, the original output with the original input. I don't care about the intermediate just to help me to write down the equation. So if you substitute back W with its expression, you're gonna have A plus B or A or B in bracket, and this should be ANDed with C bar. So this is the way how to write down the Boolean expression for this circuit. So it's just a matter of knowing the individual gate expression, and then you can substitute back in order to represent X as ABC. So you want to find the relation between inputs ABC with the output. So this is expression. Now let's talk about truth table. What do you mean by them? How to build them based on a given circuit or given Boolean expression. So in terms of definition, just verify the relation between input and output, and show the output in terms of logical operation of all the possibility of the inputs. So rather than going to the definition, I want to find the relation between input for the output for all the possible situation for the input, in order to study what happened for this circuit, what this circuit will give me. So to know the number of possibility of the input, this is the first thing that you know you have to know in order to build a truth table for any given circuit. You have to look for the number of all the possibility of the input in order to study all the situation for that circuit. So in order to find the number of input or the number of rows, you're gonna follow this simple relation. So to find out the number of rows, you need to take 2 to the power of the number of input in order to know how many rows that you need to write to study for all the possibility of the input. So for example, this circuit, the circuit we take it at the beginning. How many input does it have? How many different letters does it have? This is what we mean by input. So firstly, you can see that it has 3 input. Based on that, so I have A, B, C, which is the number of input 3. Based on that, the number of rows in this case should be 2 to the power 3, which is 8. And this is how I build the truth table, by looking for the number of input. So this is my truth table. It has 8 rows, 1, 2, 3, 4, 5, 6, 7, 8. We want to find now the input, how to fill it down in order to state all the possible situation. In order to write down the inputs, you need to start from the right with some input, let's say C, and I consider that C, I will write it down as 0, 1, 0, 1, and it should be changing each time. So it's gonna be repeated to have some repetition for each time, 0, 1, 0, 1. So this changing will gonna be row by row. How I know the number of repetition? You can relate it to the position of the C letter. So in digital, and most of the time we start numbering the position for any digit by considering that position to 0. So this is what I mean by 0. So if you raise 2 to the power 0, you gonna indicate how many times that you're gonna repeat the 0 and 1. So this is what I mean. So you're gonna write 0 1 0 1. So you're gonna change it each time, each row by row. For each row you're gonna change it, it's gonna be different from each other. So this number 2 to the power 0 gonna tell me for each row how many times that I gonna change. Let's look for the second column in order to understand it. So the second column, which consider the second position, it's gonna consider as 2 to the power of 1. So 2 to the power of 1. So this is the first position, 0, start with 0. Second position, start with 1. And if I raise it to the power 1, the answer is gonna be 2. So in this case, I'm gonna change 0 after 2 rows. I'm gonna write 0 0 and change it to 1. I write the 1 2 times, and so on, and until I complete the column. So 0 0 1 1 0 0 1 1. So this is what I mean by repeating after multiple of repetition based on the position of the input. So this is, you can the position, you can define it anyway as long you following the right way. While for A, in order to find the how many times you need to repeat the zeros for the third input, so you need to raise it to the power 2 since this is the third position, and the answer here is 4. So we're gonna write down 0 4 times, then I'm gonna change it for the ones, and by that you complete the table. So this is how to write down all the possibility of the input, and this is my maybe some procedural way. You can follow whatever you want. So some others say that I can write down 0 1 0 1 0 1 0 1, and second column 2 zeros 2 1s 2 0 2 1, and then 4 zeros 4 1. Okay, what about if you have 4 input? How many zeros that you're gonna write? So in order to know that, you need to raise it to the power of the position of the new input. So if you have, like, let's say D, fourth input, the position for it 2 to the power 3. So you're gonna write 0 0 8 times, and then 1 time 0 0 0 0 0, and so on. So this is 8. It's gonna give me how many times I gonna repeat the 0 after in order to change to 1. So this is basically how to build the truth table, the input for the truth table. But we don't finish yet for the truth table. We want to find the output relation. In order to study the output relation, we need to know the logical operation done for the last logic gate. So if you look for the circuit, so this is the circuit. You can see that I want to find the relation between I want to find the output based on what happens if I change the input for different possibility. In order to find out the output relation, we have some intermediate output that we want to find it in order to help us to find what happened for X. So X, to find out the output for X, you need to know the what happened for W and what happened for the second line that enter the last gate. فبكل بساطة نحن نطلع الاوتبوت تبع اخر لوجيك جيت. عشان اعرف اطلع الاوتبوت لازم اعرف الانبوت اللي يدخل لي X. فحطلع كل واحد لحال على اساس اقدر اطلع X في النهاية. هطلع W تبع كل الحالات تبع الانبوت، بعدين نطلع Z تبع كل الحالات. So for W, we're gonna see what kind of operation that you're gonna do in order to get W. Obviously, you're gonna have OR operation between what and what? A and B. So we're gonna do OR between A or B. So we're gonna only look for these two column and gonna do OR operation. What OR operation gonna do? If you recall what we mean by OR operation, if you have 1 at least, then the answer is gonna be 1 directly. If you have 2 0, the answer is gonna be 0. So 0 0 0 0 0 0 0 1. So we have 1 here, 1. We have 1 here, 1. We have 1 here, 1 1, and it's gonna be 1. So this is what we did for W. I do OR operation between A and B. I don't care what happened for C. I only look for the column B, A and B, and do OR operation. I'm gonna do the same thing for the second line, the input for the last gate, which is Z. Okay, how to get Z? If you look back to the its gate, it should be not. Not for what? Not for C. So you're gonna do not operation on C in order to get Z. So this is the column C. I'm gonna do the operation on only C. So what the not operation means? Just take the invert. If it is 0, put it 1. If it is 1, put it 0. So this is 1 0 1 0 1 0 1 0. So this is for the this is the input for this gate. Now I can find the output X by looking for by doing AND operation between W and Z. So we're gonna do AND operation between W and Z, since this is the two that gonna enter the AND logic gate. So 0 1. So what do you mean by what happened? What does mean for the outputs? In order to get 1 for AND operation, you need to have both of the input should be 1 in order to have the output 1. So are they 1s? No. 0. Are they 1s? No. 0. Are they 1? Yes. Here no. Here yes. Here no. Here yes. Here no. So this is the output for this circuit. So it does not have a direct relation. You need to study column by column in order to find the final relation between X and ABC. This is what we want to study by for any kind of circuit. As long as you know the typical operation for each individual gate, you're gonna do it individually for each line. Then in order to find out the final output for that circuit. So this is typically the way how to deal with the logic circuit. We have to convert it to Boolean expression in order to study the output-input relation based on Boolean formulas. If you want to simplify it, then you're gonna simplify the formula. This is what we're gonna take next time. Also, you want to find out what happened for the output for all the input. So we saw that how to build the inputs table in order to see what all the possibility. Then we saw how to find out the output by going one by one for all the logic gate in the circuit in order to study what happened for the output for all the possible inputs. So you're gonna apply the same thing in practice. I'm gonna use the same circuit, this circuit. I'm gonna try to build it and try to verify what we have in terms of truth table. So truth table is just the final answer that I want to have after building logic circuit, because I want to study what happened between A, B, C and X. So in order to build the truth table, you're gonna bring one OR, one AND, one NOT. The best way to order the position of the ICs, you need to make sure that the last one should be closer to the output, and the first one, second one does not have priority, so you can put it any way you can. So I start with OR 7432. This is NOT 7404. And this is AND 7408. So I place it, I order it in this way. Since my connection gonna be nice and clean, so I do not confuse with the connection. So how to connect the circuit? You need to bring 3 switches or 3 inputs. The first input A, B, C. This is my input. This is the switches that I'm gonna use, since the circuit using 3 switches. And the output, we have only one output, X, which is the LED to indicate. If it is 0, it's gonna be off. If it is 1, it's gonna be on. Now let's try to connect. I start with the first gate and I connect it according to the data sheet for that gate, or the connection, open the connection diagram for that gate. So you know that 14 and 7 should be the VCC and ground. So once you place the IC here, so this line will take 1, 2, 3, 4. This should be the way of numbering, since the notch of the IC is placed here. بما انه النotch here فالتعداد حيبدأ من يسار النotch هذا، فواحد 2 وهكذا، بعدين 8 لين 14. فأنا أول شيء بشبك الباور لاين VCC ground. So VCC 14, it should be to the 5 volt, and ground should be connected to ground or the negative or 0. فالخط هذا كله يمثل لي 5 فولت، وهذا الخط كله يمثل لي نيجاتيف أو الجراوند. طب okay, now I connect 14 and 7. Now I want to connect 2 input and I have 1 output. So which 2 pins that I'm gonna consider? Let's take the first 2, 1, 2 as my input. So A, we're gonna connect it to 1, B, we're gonna be connected to 2, and the output for this 2 is gonna be W. So this is the yellow dot, it should be W. I call it W since to ease my connection, to make my connection easier. So this is the output, and I just leave it at the moment, but I need to know that this is where I gonna take my output. Now I go to the next logic gate, which is NOT. I do the same thing. I bring the data sheet, I look where it is the VCC, what's the ground, what's input that I will take for that logic gate, and how to number the IC. So since this is the notch, so the number starts from here, 1, 2, 3, 7 and 8 until 14. So now I'm ready to connect. I know that this is the line for 14, so I take 14, connect it to the 5 volt. So we're gonna connect it here, and the ground we're gonna take it from 7 connected to the ground. And this is how to connect the power line for the NOT gate. Now I want to connect the input. From where the input coming for the NOT should come from C. So we're gonna bring wires from C connected to 1 in the NOT. So you can take any one of them. I take one just randomly. Since you take one, you need to take the output corresponding to that input. So what's the output? Should be 2. So this is the output for, which is Z. It has the same color, Z green. The W have the yellow one. Now I go for the third IC, which is OR. Oh, sorry, and I place it correctly. So this is the notch. The number is starting from here, and it's gonna be considered as this way. Now connect the power lines. 5 volt, we're gonna connect it to 14, similarly to the other, or similar to the other. So the whole line here is 5. So this is the way how the breadboard is working. The Y7 should be connected to the ground. So this is the ground. The whole line here is ground. Now I finish up from the powering up the IC. I want to connect the input. So in this case, let's take like different input. So it doesn't matter if you take 1, 2 again, but let's say that I want to take 4, 5 as my input and 6 as my output. So I bring the first input, which is the ones that come out from OR. I call it W. I connect it to 4 in the AND. So whatever come from OR, it goes to AND based on the diagram. So the diagram we're gonna help me to do the connection. Okay, what about the second input 5? So I'm gonna bring whatever come from NOT. Where is that? This NOT, since I choose the first line as my input. So this is the output for the NOT, and the output for the NOT we're gonna goes to 5, since I choose 4 as my input and 5 as my input, second input for AND. Now what's the output for AND? It's based on choosing 4, 5 should be 6 and should be connected to the output. By doing that, I'm completing the connection. Now I try to study what happened for the all the possible situation for the input by looking for the truth table. So I bring the truth table. I want to verify what I have. So the first way, I gonna make all them 0, 0, 0, 0, A, B, C, 0. And if you do that, you're gonna have 0. This is what you're gonna see in practice. Now I make this 0, I make the second one 0, third one make it 1. Let's see what happened for the output. It's gonna be 0 again. I want to now go to third row, 0, make the this one, I make this one 1, and the third one make it back to 0. Now let's see what happened for the output. This is what we have, 1. Now go for the column, 0, 1, this is 1, and this is what we have. Then I make this 1, 0, 0. Let's see what happened in this case. We're gonna see that it's gonna give me 1 in practice. This is what we're gonna see in practice. Make this 1, 0, 1. The answer or the output will be 0 if you do this operation. If you make this 1 and the second one 1, the third one is 0, then this is what we got in practice. This now I just doing what you're supposed to see in the lab. Make this 1, this 1, and all of them 1. If you make it all of them 1, this is what you got. This is the truth table for this circuit. If you try to compare it what we have last time, this is gonna have the same answer. So gonna have only 1 at this and this and 3 situation, and the other will be gonna be 0. Try to look back and compare the result for the experiment to what we found out in the truth table example. Now let's take another example. Let's say that I'm having this circuit. Now I need to connect it in breadboard. How to connect this circuit? You have to know how many gates that you used and how many inputs that you need. So obviously you need only 2 gates, and the second one is OR. So you're gonna bring AND connected at the left, and gonna bring OR connected right, so it should be closer to the output. So how many input we have? Obviously only having 2 input. Although we have here 4 wires, I don't care about how many wires coming from the left side. I only care about how many letters I have. So I'm having only two input, AB. And how many output? It's obviously one, and it is Q. I call it Q. And I label this two intermediate wires by some names. They call it W, call it Z. And I start now to connect. So connect the AND. What's the input coming inside AND? A and B. But first let's power up the IC. So this is the notch, this is the numbering 1 2 3 7, and this is 14. So 14 should be connected to 5, and 7 should be connected to the ground. Now I want to connect the input. I take one wire from A, connect it to 1. Yeah, you can choose 1 and or choose 4 or choose whatever you want. I choose 1 here arbitrarily. B connected to, since you choose 1 you need to connect it to 2. And the output, just leave it at the moment, but you need to know that this is where you're gonna take the output. Just I label it yellow in order to say that this is the output, W. Now I go to the second gate here, OR. So go this OR. I'm gonna connect. At the beginning you need to power up the IC. How to power up the IC? You need to know the numbers order for the IC by looking for the notch, and should be starting from here 1 2 7 and it's 14. So 14 gonna connect it to 5 volt, and for 7 we're gonna connect it to the ground. So now I power up the IC. Now I want to connect this gate, the OR. What's the input for this gate? One's coming from B and the second coming for A. So you can take it B directly, or you can take whatever you place at this line. So this line becomes B. Since you put B here, this line becomes B. So you take wires from here and connect it to one of the gate inside the IC. So first I choose the first one, 1 2, as my input for this one. Sorry, this I start with A here. So I take this line is A, I connect it to 2, for example. So A connected to the 2, second input for OR. And B, this line B, since I choose this bin or this hole, all the these 4 bins becomes all B. So whatever I take is gonna be B, since they are considered as at the same column. فأي نقطتين على نفس العمود يمثل لي نفس الانبوت. هذا A نفس العمود، B نفس العمود، فأنا أخذت B شبكته في واحد لل OR gate. So I'm now connecting 1 2 as my inputs. So this is 1 B connected to B, and this is 2 connected to A. Now I want to find out the output for that. What's the output? Should be 3, and I label it green to indicate that this is the output for that gate. Now I left up with the last gate. I know I need to connect its input. So what's its input? I need to connect W, this one, the ones coming from the AND, the output coming from the AND, and the output coming from the first OR. So this is the output from first OR, this is the input for, this is the output for first AND. I bring all of them connected to one of the gates. So since this I don't use it again, I use another one. So let's say that I use 4 5 6. So I connected the Z, the output from OR, to 5. Doesn't matter 5 or 4, doesn't matter order, but you can follow what you need. So whatever comes from OR, it goes as the input for the second OR at 5. Since you choose 5, you need to connect the first input W in 4. So W, we're gonna go to 4. So 4 for W and 5 for the Z, the output from the first gate. Now I choose the WZ as my input. I left with the output. What's the output? Where's the output? Should be 6. Since you choose 4, 5, then you need to choose 6, and you need to connect it to the output Q. Now I left up with study all the possible situation for this circuit and try to verify what kind of circuit that I have. So let's start 0, 0. Make all of them 0 and see what happens. In the lab, we're gonna see that the output is gonna be off or low, 0. Now let's make this 0, make this 1. The LED will gonna be 1, or the output is gonna be 1 in this case. If you make this 1 and the second one is 0, the LED will become again 1, stay 1. Now let's make this 1 and the second one 1 and see what happened for this output. Gonna be 1. Try to verify what kind of table we have. If you don't recall it, this should be OR. So rather than connecting 3 gates, you can just bring OR gate and you're gonna have the same answer. This is what we're gonna take in the next experiment. Try to simplify a circuit in order to reduce the amount of the used logic gate. فالمرة الجاية بدل ما استخدم كذا جيت مع بعض، أنا بستخدم جيت بسط الدائرة كلها على أقل عدد ممكن، بحيث إني أختصر عدد اللوجيك جيت المستخدمة. هذا مبدئيا بالنظر إلى التيبل أنا كان نستخدم OR، لأن OR هو يعطيني 1 إذا كان واحد من الانبوت 1، ويعطينا 0 إذا كان الاثنين 0. So this is it, and see you next time.